Module 6, Lesson 5, Area of Triangles and Compound Figures. Area of triangles and compound figures. To multiply three or more numbers, multiply two numbers at a time. What is 1/2 times 6? 1/2 times 6 is 3. What is 3 times 4? 3 times 4 is 12. Minimize that. Let's scroll on down here. So you get the idea. You take 1/2 times the first number, so 1/2 times 6 was 3, and then 3 times the third number, which was 4. 3 times 4 is 12. So let's look now at problem 2. From any vertex of a triangle, a perpendicular line, so that means it's perpendicular, that little box means it's perpendicular, it can be drawn from the vertex to the opposite side. So here's the vertex, the line is drawn to the opposite side, or an extension of the opposite side of the triangle. The length of this line segment is called the height. It's called the height of the triangle. It is represented by the letter H. The side of the triangle that is perpendicular to the line segment that represents the height, or this line right here, is called the base. The base of the triangle. Its length is represented by the letter B. In problem 2a, the height of the triangle is shown by the dashed line segment right here. Dashed line segment. What is the length of the base of this triangle? It is 9 feet. So 9 feet. What is the height of this triangle? Which is here, denoted by the dashed line, which is 4 feet. 4 feet. Let's take a look at B. The triangle in problem B is a right triangle. In a right triangle, the height is measured by the length of a leg of the triangle. So the height is measured here by this leg. What is the length of the base of the triangle? So right here is the base. That is indeed 2 inches. What is the height of the triangle? 1.5. Excuse me, 1.5. That is not a point. 1.5 inches. So now we know how to figure the base and the height. The dashed line from a vertex perpendicular to the opposite side, or in a right triangle, it is one of the legs of the triangle that is perpendicular to the base. Now let's look at problem 3. The length of the base and height of a triangle are used to find the area of the triangle. The formula for the area of a triangle is 1/2 times the length of the base times the height, or 1/2 BH. A equals 1/2 B times H. Use the formula to find the area of the triangle in problem 2a. Substitute the values for B and H into the formula. In the triangle in problem 2a, what is the length of the base? 2a, this is the base, therefore the length is 9 feet. 9 feet. What is 1/2 times 9? 1/2 times 9. Excuse me, got ahead of myself. What is the height of the triangle? Well, the height is here. So the height is 4 feet. So now what is 1/2 times 9 times 4? 1/2 times 9 times 4 is 18 feet squared. 18 feet squared. The length of the base and the height of the right triangle in problem 2b have been identified. What is the length of the base of the right triangle in problem 2b? It is 2 inches. The base is 2 inches. What is the height of the triangle in problem 2b? It's 1.5 inches. So now what is the area of the triangle? It is 1/2 times 2 times 1.5. So 1/2 of 2 is 1, and 1 times 1.5 is 1.5 inches squared. 1.5 inches squared. 1.5. Moving right along. Let's take a look at number 4. Let's take a look at number 4. The figure in problem 4 is made up of a triangle and a rectangle that are joined, or it's considered a compound figure. Okay, so the figure is made up of a triangle and a rectangle. They're both joined. So the formulas for the area of a triangle and the area of a rectangle can be used to find the area of this figure. So we're going to split this figure into two shapes that we know. We're going to split it into a triangle, which is going to be our A1, and a rectangle, which is going to be our A2. So now, in problem 4a, we're going to find the area of the triangle. The triangle's area is labeled as A subscript 1, or A1. What is the length of the base of this triangle? The length of the base is here, and this is going to be the same distance as this distance here, so it is 40 inches. What is the length of the height of the triangle? Excuse me. We're looking at, height of the triangle. It's right here. Height of the triangle is 20 inches. So now what is 1/2 times 40 times 20? Is 1/2 times 40 times 20. It is 400 inches squared. 400 inches squared. Now, in problem 4b, we're going to find the area of the rectangle now. The rectangle's area is labeled as A subscript 2, or A2. What is the length of the rectangle? It is the same as the base of the triangle. It's 40 inches. 40 inches. Whoops. 40 inches. The width of the rectangle is what? The same as the height of the triangle, isn't it? That's pretty coincidental, which is 20 inches. 20 inches. So now, area equals length times width, or 40 times 20, and 40 times 20 is 800 inches squared. So now to find the area of the entire compound figure, we take A1 plus A2. So A1 was 400 inches squared. If I can type today, 400. A2 was 800, for a total of 1,200 inches squared. 1,200 inches squared. So that gives you the area of a compound or a composite figure. It's a figure that combines figures that we know how to find the area of. In this case, it's a triangle and a rectangle combined. We find the area of the rectangle, and the area of the triangle. We add those together. Our total area is 1,200 inches. 1,200 inches. So now let's go on down to the build the concept. Okay. The rectangle shown at the left is divided into what two shapes? It's divided into two triangles, two right triangles to be exact. To find the area of the rectangle, find the area of each triangle and add them together. What are the length and base and height of the triangle with area A1? Well, we know that the base is 2. We know that the height is 1.5. So it's 2 times 1.5 equals 2 times 1.5, which equals what? Oh, excuse me, 1/2 times 2 times 1.5, which equals 1.5. It's 1.5 inches squared. Okay? Everybody with me? That is the area of triangle 1. So now let's take a look at the next triangle. The area of this triangle was, So what is the area of A2? Well, they're congruent triangles, aren't they? They have the same height. They have the same base. So again, it is 2, times 1.5, which is 1/2 times 2 times 1.5, which is indeed 1.5. So we add both of those together, 1.5 plus 1.5, and the area of our rectangle is 3 inches squared. So the area of the two triangles is 3 inches squared. So let's take a look at the rectangle. The area of the rectangle is length times width. What is the length of our rectangle? It is 2. What is the width of our rectangle? Or the height? 1.5. What is 2 times 1.5? 2 times 1.5 is 3. So what do you notice? The area of the two triangles is, what? Is it different? No, it's equal to, oops, wrong spot, is equal to the area of the rectangle. So we made it a composite figure, we used two triangles, and we made it just a single rectangle. And we proved that the area of the composite figure is indeed the same as the area of the whole figure. So let's move on to the try it together. Okay, let's take a look at number 5. In number 5, notice that the height of this triangle is measured outside the triangle. The height is indicated by the dashed line perpendicular to the extension of the base of the triangle. So the base of the triangle is actually here, and in order to denote the height, they've extended the base and drawn a line perpendicular to the vertex right there. So this is our height. Our height is actually 6.3 feet, and our base is actually 8.4 feet. Okay? So now, what is 1/2 6.3 times, well, it's actually base, so let's do that first. 8.4 times the height, which is 6.3. 1/2 times 8.4 times 6.3, and it's going to be measured in what kind of units? It's going to be measured in square feet, because we have feet times feet, which makes feet squared, or square feet. So the area of this triangle is 26.46 feet squared. And that's really not a good way to do this on this computer keyboard. So we'll just kind of do it like that. 26.46 feet squared. Now, problem number 6. Problem number 6. What are the dimensions of the rectangle? Well, we have a composite figure here, which is a rectangle and a triangle. So the first thing we're going to do is we're going to find the area, our A1, which is our rectangle. And to find the area, we need length and width. So our length is what? 17 feet. 17 feet. And our width is 7 feet. So now what is 17 times 7? 17 times 7. 119 feet. If I can find the key I'm looking for again. Feet squared. Okay, so area 1 is 119 feet squared. Now we're going back to the triangle. The height is denoted by the dashed line. The base is here, which is parallel to here, which means the base must be what? 7 feet. It's going to be the same as the width of the rectangle. 7 feet, Lynn. Feet. And our height is denoted here by the dashed line, which is marked as 5 feet. So 1/2 times 7 feet times 5 feet gives us what? 17.5 feet. 17.5 feet, because 7 times 5 is 35. 35 divided by 2 is 17.5. So 17.5 feet squared. So now if we take 119, we add 17.5, or 17.5, we come up with a total area for our composite or compound figure of 136.5 feet squared. And that does it for area of triangles and compound figures. Area of triangles and compound figures. Now once you move on to the next page, you move on to Skill Building New and Review, You may use this work on your own. The how-to. The how-to tells you in symbols and in words how we just computed the area of triangles and the area of compound or complex figures that include triangles. So you may use this information to assist you with page 27 or the skill building new in review.